Hey, Topic Analyze Math and History, and we are going to learn about how to calculate a specific heat. So, when you think of temperature, or when you think of how hot something is and how cold something is, you might think of So those can be examples of temperature. When you measure how hot something is or how cold something is. But what we're going to measure is if I put this thing in a liquid, what is the change in temperature and how much energy was used for that action to happen? Here's an example. If I throw an object in water, which is 4.184 joules per gram times Celsius, and the change in temperature increases by 10, what is the energy, what is the amount of energy in joules to make that happen? So, in the last video, we said that joules was a unit of energy, and grams is a unit of mass, and Celsius can be a unit for temperature. So if I throw this mystery object into the water, and the water's temperature, no, not the water's temperature, the water's energy is 4.184 joules per grams per Celsius. So every time you have a Celsius in water, and you have 1 gram of water, the energy of the water is 4.184 joules. So that is the unit of energy water has, 1 degree Celsius, 1 gram. So if I toss this object into the water, how much energy, what's the amount of energy for it to increase by 10? Well, there is a formula that we're going to look at. To find the energy to make the water increase, the temperature increase, you have the energy in joules represented by the letter Q is going to equal the mass in grams, that's how much the object weighs, or how much particles are in it, multiplied by the specific heat by the change in the temperature. So we're going to use this formula to solve it all out. What we can do to get our information is we can put them on a chart like this and find out what they mean and find out what our letters are. So we said that we need to find the letter Q, or we need to find how many joules there are. And we already know that the mass of the object is 5 grams right here. So we're going to put 5 right here. The C represents the liquid state you toss the object in. And since we tossed it in water, we're going to put 4.184 joules per gram if you have 1 degree. We are not going to use TS and TC because we haven't really known yet what the initial temperature is and the final temperature. We would only use these if the problem was literally stating what the temperature was before and what happened after it changed or when it changed. So we're not going to use these, but the next problem we will. The change in the temperature is going to be 10 degrees Celsius. The Greek letter for delta represents the word change in mathematics. So I guess we can solve it all out. With the formula right here, we can say our energy in joules is going to equal 5 multiply that by 4.184 as the mass of the liquid, and that is going to be multiplied by the change in time, which is 10 degrees Celsius. So 5 times 4.184 times 10. When you do that on a calculator, because you can't really multiply easily mentally with a decimal, you would be able to get the energy would be 209 joules. 209.2 joules will be used to change the temperature if I toss that object into water. So we solved an easy and simple problem. Let's solve another one so we can apply what we have and see what happens. So this is the final problem of the day. What is the specific heat of a material if 24.8 grams of metal absorbs 275 joules of energy? The temperature rises from 20.2 degrees Celsius to 24.5 degrees Celsius. So what is the specific heat of the material? So what we already know of, when we put it into our letters right here, we can say that our amount of energy is 275 joules. We can also say that the mass of the object, the mass of the metal, was 24.8 grams. We now understand what the initial temperature was and the final temperature. The initial temperature is the one before, so we can say 20.2 Celsius. And the final was 24.5 Celsius. When you find your change in temperature, that will bring you to the difference between these two right here. So we're going to say 4.3 Celsius. That's how much has changed to get from here to here. The thing is, we have to find what C represents. We have to find out what the specific heat is. But there's something wrong with our formula. Right now, our formula is wanting us to say, find the letter Q or energy in joules. However, we have to change the formula. Have you ever learned about what literal equations were in your last few years of mathematics? We would change this formula that we would rewrite it in a different way, but try to find one of the other variables by itself. So we want to isolate the letter C right there. Let's sort of circle it so we know not to touch it. To get the letter C alone and to easily find out what the specific heat is, we can divide everything by M and the change in time. When we do that, we get Q is going to be divided by the mass times the change in time. It's going to equal C, or the specific heat. To rewrite this equation, we can turn it so C, or the isolated variable, is on the left side. C is Q divided by M times T. So now we can use our formula now. Now if we plug in the numbers from here into this, we'll get what C is. Okay, so we want to find C. What we already know of is 275 joules goes on the top. That represents our letter Q. Divide that by the mass is 24.8 grams. 24.8 goes right here. And we have to multiply that by the change in time, which is 4.3. That is the change in time. No, change in temperature, I meant. Change in temperature. When we solve this out, we have to multiply 24.8 by 4.3 as the change in temperature. When we do that, we do 275 divided by the answer you get from these. The answer for the entire problem is the total amount of heat, or the total amount of specific heat of the object, is 2.58 joules per gram times Celsius. In this case scenario, 2.58, the metal that is absorbing 275 joules of energy and changes the temperature from this to that, the metal is 24.8 grams. But 2.58 grams of the metal, the joules per gram times Celsius. So every 1 Celsius, you have this much of energy in the metal if you have it weigh 1 gram. So that is how we can find the specific heat. I hope this video has helped you understand how to find the specific heat of a liquid and an object. Thank you for watching Talpingo Life's Math Industry. Like and subscribe.